Hi, I'm Pagata12 and today we play with collisions and we cover two methods. This one will have two parts. So in first one we'll go naive. In the second one, not so naive as you can get up to tens of thousands of collisions. Okay. However, for my patrons, I'll have another two methods. One is a hash table and also spatial hash in a 3D, for which I integrate Verlet. And yeah, you can join me on Patreon. You'll get access to a bunch of advanced things. And let's go back. Let's start with this one. So we build this component. You just drag it into your feedback like this, and yeah, everything it's solved. We have some other outputs. You might find them useful in some cases, and yeah, well, for example, I want to see the spheres that are still touching. Okay, so even they solved collision, like here, you see they are still touching, and yeah, we solve this, let's say this little issue maybe. Yeah, so let's start from scratch. I leave this aside to guide me. Okay, and let's see what we need. Let's use a constant chop for the resolution of our texture in which we have the particles. Okay, so maybe the name, a good name would be map X and map Y. Okay, let's go with 24 by 16. Okay, now with a noise stop, RGBA, and I'll set nearest pixels to better see the pixels actually. And let's use this. Okay, now we have 384 particles, and we can increase this. Let's go into a feedback. Now also drop the keyboard in. Okay, and pulse and reset the feedback, and then a null. I name this null position and I drag it back into the feedback. Now we have this network, and let's build this component. So here we chain a null, click outside, collapse selected. Let's call this naive. Okay, and let's set some things here. So customize component. The name would be collision naive, and we need the radius. Okay. What else? Some randomness for the radius. Okay. So what else? Something like power, and I'll show you that, and also a momentary pulse, as we're gonna use the feedback inside there. So yeah, that's pretty much it. Okay, now let's set the radius 1 divided by 32, the randomness 1 divided by 3, the power, let's say 1 divided by 8. Okay, and let's go inside, and yeah, we have this input. Let's use info to grab the resolution, and we're good to go. Now we group this texture, as I want a bunch of cells containing the our particles. So actually we duplicate this texture 384 times. So yeah, there are a lot of them. Let's see them nearest pixels. It's very important, nearest pixels here. So now let's subtract this like this. We mask the alpha, and here we use a math, and we go with Pythagoras, with length, mask the alpha. This should be mono, like this. And I said we need something for the randomness of the radius. Okay, what if we use noise? Okay, let's go seed 2, 1 for the offset. Here we need to bring the parameter. Okay, so we have the parameter. Now the randomness goes here in the amplitude. Okay, we good here. Now this only takes the noise. It's let's make it mono. Okay, and maybe a lower value here. And now I use a limit. Because the moment you increase this amplitude, you will have negative values. And now I want to cover that. So we zigzag minimum, and not from the 0, but 1 divided by 8. Not to have very, very small spheres. Okay. And we do the same with this group, because we need to add radiuses from each spheres to all the others. So we do like this, add. Okay. And now we need to multiply this with the radius. Okay. Okay, so here is, I would say, sum of the radiuses. Okay, this is the distance. Okay, now I subtract those two. So yeah, here. Okay. So here I subtract those two, and I want to check where I have negative values. So right after I go with math and ceiling. Okay, and I need to invert this, but first we clamp it. So we clamp 0, 1 and invert this. Okay, now you see we have some points like on a grid, and those are the ones that are checking with themselves. Okay, so yeah, maybe it's good to clean them. Right here we can use a math with ceiling again, and yeah, again a level like this. And now you can see we have this grid. We can subtract this. So for those points here, I need to solve collision. Okay, and how can we do this? Let's bring a normalized component. So everyone, this is let me connect this subtract. This is a composite with divide with the length of the vector. So yeah, nothing really hard. Now this is the vector direction on which we need to solve the offset, okay? How much of that direction we need to displace, let's say. It's we have it here in this subtraction. Let's go with the math and take half of it, okay? In this subtraction we have the overlapping, okay? And now we multiply like this, okay? And also multiply with the pixels that we need to solve for collision, okay? Like this. And now here is the texture that we can add. Let's use a select. So having in mind this is way bigger than this one, but we need the resolution of the second. So we just go with add. Okay, and out here. And let's make sure everything is okay. We already did wrong, but and this is because we went in blind. Let's try to visualize what we're doing. So what if we split here? We take the geometry, and right now we don't have any, but let's have some. Okay, let's have a geometry component here, and I need this parameter. I will drag the radius. Okay, if I go inside and I don't need this, we go with the sphere instead. I will drag the radius. Okay, let's go for the polygon detail 4. Okay, now this takes instances, and let's go with position R, G, and B. Okay, and yeah, it's messing. We didn't solve anything. Okay, let's go inside, and we still have to do some things before we add that result, because it's not here the result. Here we have a texture with all the distances that we need to solve, and let's use image filters, pixelate. Pixelate, what pixelate does, it makes the average, and we need the sum, okay? And that means, let's open this a little bit, because we need to pixelate with the same resolution, like here. And right after, I use a math for multiplying with how many values we took the average from. Okay, so the values are 24 multiplied with 16. So okay, so y here. This is good. Now I would like to go inside and make sure everything is nearest pixels. Okay, I copy paste this and I connect this resolution where I have the 0, 1 values. Okay, and now I have those two textures, and I go with composite divide, like this, and yeah, maybe now. Okay, and I believe what is needed here, we switch those inputs and take input 1. It's still a little bit strange, but we going there. It's something like oh, we have this mono here, it's not good. So this composite divide takes the input 1. Okay, yeah, Now it's good. And let's see that. Okay, now first I want to have an output right from here, right from this limit. This would be output 2, in which we have the scale, the randomness. Okay, and another out from here, and we need to do something with this, because this is a big size. So we either solve it right here, or maybe we go with like this. So let's see if we can solve it here. So this would be out 3, I believe. Okay. Now for this, let's drag some colors. Okay, so I will drag position, or no, let's have a noise. Let's have a noise for the color. And yeah, nearest pixels, this is like this, null. Okay, let's go for the colors, RGB. Okay, and now I want to check this texture, because it seems like we still have some touchings. Okay, so either you take this, make it our size, or I will try to see if we can judge it out of here. Okay, now for this I will go with screen. And yeah, I can see the ones that are touching. In the first second, I've noticed some of them are pretty white, and this is because I believe we need to limit this. Okay. And yeah, let's see now. Maybe if we increase the radius 1 divided by 24. Okay. So some of them are still white, and the collision is solved, but they are still touching. And one way to solve this, it's something that let's name this position. This is color. Okay. So remember, we have this power here. Okay, let's use it like some energy, momentum, or something. I will have a constant with the same resolution here. Okay, and this is 0. We multiply those two, so we have 0. I use a feedback. Obviously, here goes the pulse. Okay. Okay. Oh. Customize component, pulse, and this is momentary. Okay. Add. Let's drag it to the bottom. Okay. And now if we go inside, we have it here, view, and now we can use it on our feedback. So pulse. Okay. And now we add the feedback with our vectors. We use a mod. and in each frame I drag the add into the feedback, and in each frame I take a little part of this. Let's go with 1 divided by 3, okay? And actually it's the power, so let's go with the power, okay? Now everything is set, okay? Let's drag the feedback here. Now you see we don't have white circles anymore. The energy, the power makes them go out of overlapping much faster. And yeah, if you play hard with this value, you might end up with a little mess, because yeah, if it's too big, you'll have some kind of explosion. So you might like this. And yeah, what else I want to show you is what if we use a limit? So we use a limit, and let's go zigzag 0, 1. And yeah, we have this. And yeah, we still don't see any difference in the sizes, and this is because we don't use it yet. So let's go in the instance, and we scale with naive out 2, and we take the red from there. Okay, now yeah, now it's much better. With this limit, we can put them inside 0, 1 cube. Let's have a bunch more. So we increase this to 48. Let's say we'll have 2 times the amount. Maybe 32 here. We'll have plenty more. Okay. And yeah, there are a bunch of them, and the full solving or will take some times now. Okay. What else I want to show you? If we increase this a little bit more, okay. Now you see the limit. It's taken in the center, and I was wondering how can we have some nice limitation according with the radius, and so my patrons will have that addition. So box limit, it takes the radius. We can grab it from the naive component, okay. And then we connect the first input is the position, and the second input is the scale, the randomness, okay? And if we use this limit, yeah, we can have nice packing inside the walls of our 0, 1 box. And yeah, what else I want to show you? You can use, let's make this a little bit smaller, maybe. Okay. And let's use blur now. And yeah, we go with horizontal, and now obviously blur works on average with the neighbors, or the position will be clustered a little bit, so we'll always have this white. Okay, now let's do like this. If we go with a repeat instead, we have some rings, you see. And yeah, if we increase now the, see, or you can go with plenty more, 64. Okay, they need to be way smaller, and to match the colors for this, maybe you need to use a noise, which is let's take the Y, only 1, like this. This is RGB, not monochrome, and now with group, Okay, we group 48 times, and now, yeah, we use this. We have different colors. Okay, so yeah, this was my tutorial. I really hope you like this. You can play with it, and yeah, it doesn't really matter. It's naive. You can go up to 2,000 or 3,000 spheres. You don't have a limitation for the non-commercial, like in previous methods, in which you were limited on 1280 for the amount of the particles. So I really hope you like this. Thank you so much for watching. You can support me on Patreon. You'll get access to a bunch of other stuff, and you'll help me going on with this research on computation in textures. Thank you massive, and thank you so much for all my patrons. See you in the next one.